All right, so in the last class, we were doing intertemporal choices. So intertemporal choices is a very important topic. Now, the way you have to work with intertemporal choices is, so ideally in the first part of consumer theory, what we saw is that in a single time period T, a consumer was consuming two goods, X1 and X2. So we had to decide how much of the good X1 was being consumed and how much of the good X2 was being consumed. In intertemporal, what we have is the same good is consumed in two time periods, T1 and T2. So you have X1 as consumption of the good X in period 1 and X2 as the consumption of the good in period 2. So instead of thinking as the same commodity across two time periods, I want you guys to think of it as two different commodities in the same time. So imagine consumption in period 1 as good 1 and consumption in period 2 as good 2. Because when you do that, you don't need any new math. The math is going to be the same that we did in chapter 1 of consumer theory. So in the last class, we looked at how substitution and income effects play out for a change in prices. And it gives rise to this relationship between C1 and C2, which says that if you're a saver, then increase in R increases your consumption in second period, but it may or may not increase your consumption in the first period. So if you are somebody who likes to save, then if rate of interest goes up, then it will definitely increase your consumption in the second period, the subsequent period, because your savings are going to increase, right? So suppose you invest a lot in the stock market, then you know that if the market performs very well, then your rate of return goes up. So you are going to make more profit. So you are going to be better off in the subsequent period. On the other hand, if you're a borrower, then if R increases, then you have borrowed from the market, so you have to pay up more. So it definitely reduces your consumption in period, but may or may not increase your consumption in period. So this relationship is pretty important. It has been asked, I guess, once in the past 5 years. So let's look at this example. So we have a utility function u equals to under root x1 x2. I don't know. Have we done these examples? Did we do these examples? Yes.
Yes, sir, we have done these examples in the last class.
Okay, fine. So I have this question from this year's paper for you guys. So let's do this one. Let me copy it and paste it on my notes. Okay. So in this problem, we have a consumer who's living for two periods, 1 and 2, and consumption are C1 and C2 in these periods. Utility in period 1 is, utility is basically log of consumption in period 1 plus, you see, this is a little bad. I mean, they should really not use these rules for writing like that. Half of the equation is here, half is here. Makes it horrible to do. Anyway, plus 1 plus 1 by rho to the power 1. So it was 1 plus 1 by rho into log of C. They have already given you the intertemporal budget constraint, which is equal to this. Okay. So the budget constraint is basically C1 plus C2 upon 1 plus R equals to wage in period 1 plus wage in period 2 upon 1 plus R. Right? And further, it's given to me that R is greater than 0. So he's asking me a relationship between C1 and C2. So what you need to do is just optimize the utility function. That's all you need to do. So find C1 and C2, which maximizes the utility function. So do that and tell me what's going to be your C1 and C2. So in a question like this, you see this is a constant. So you can actually write this as some real I. You don't need to keep working with W1 plus W2 upon 1 plus R because it might get messy. So instead, you can just substitute this W1 plus W2 upon 1 plus R with some variable I. So you can write this as C1 plus C2 upon 1 plus R equals to I. Have I started the recording? Let me pause. Yeah. So yeah, just rewrite the utility functions. Utility is equals to, so this is a monotonic transformation. We do this monotonic transformation on this, write the budget constraint as P1 C1 plus P2 C2 equals to I, where P1, if you look from here, P1 is 1 and P2 is 1 upon 1 plus R. So MRS, that sorry, price ratio becomes 1 upon 1 by 1 plus R, so that is 1 plus R. And the MRS is just when you partially differentiate with C1 and with C2, you get this value, C2 into 1 plus rho upon C1. So when I equate my MRS and price ratio, what I get is 1 plus R must be equal to C2 by C1 into 1 plus rho. Right, so C2 C1 equals to 1 plus R upon 1 plus rho. Right, now R is given to be greater than rho. So since R is greater than rho, I know that this value is going to be greater than 1, which implies C2 is greater than C1. Right, so that's your answer here, C2 greater than C1. That's option. I just wanted you to see, wanted you to do this problem because I wanted you to see that this is nothing other than what we have done in the first part. If you have mastered the first part of utility maximization, this should be no problem. Uh, Also, this 13th question is also a similar one. So you can do it later. I'll add it to the list of past year problems after this lecture. But my point here is that it's a very important topic. And it's a very easy topic that as well because you don't need to know much apart from utility maximization. So if you know utility maximization, you can easily do this sort of problems. All right, let's do risk aversion. So risk aversion. So would you bet $1,000 on a coin toss? All right. So if I say that okay, heads or tails, bet $1,000. So most probably people would not bet 1,000 rupees on a coin toss, right? Because uh, even though it's a fair game, a coin toss like this is a fair game. Why? Because with probability half, you get plus 1,000, and with probability half, you lose 1,000. So overall, your net return in monetary terms is zero. But you would still not bet anything on this on this coin toss. So the reason is hidden in the nature of the utility function. So assume that this dark line represents the utility of a function from the wealth that it holds, and it's a concave increasing function. Okay, so it's a concave and increasing function. Let's say an example of this most probably used is utility from wealth equals to under root W. So utility from wealth equals to under root W is a concave and increasing function. So concave implies that when you connect any two line segments on the curve, the line segment lies completely below the curve. So that's concave. Uh, so this is a concave increasing function, maybe under root W, maybe other format. The point is that this sort of a, if your utility function has this sort of a curvature, then you would not bet on a fair game. Why is that? Why won't you bet on a fair game? So to understand it, let's take this example of a utility function which looks like this. And suppose right now you are at some utility, some wealth level W. This is your current wealth level W. Now, suppose you were to participate in this bet, you would get W naught plus H with half probability, and you would end up at W naught minus H with half probability. So if I were to extend these values, so you would be at this level of utility with half probability. So utility at W naught plus H with half probability, and utility at W naught minus H with half probability. So the expected utility from participating in the game, if you think about your expected utility from participating in this game, this would be half times utility of W naught plus H plus half times utility of W naught minus H. So if I were to connect these two lines with a segment, these 2 points with a segment, you would be at the midpoint of this line segment that is here. So this would be your expected utility. But if you do not participate in this game, you are at W naught level, and this is your utility. So this is your fixed utility if you do not participate in this game. So as you can clearly see, if you do not participate in this game, so utility from not participating will be equal to utility at W naught. Now, clearly, as you can see, utility from W naught is greater than expected utility from participating in this game. So a guy with such convex preferences is not going to participate in a fair game. So agents who have such utility function, they are called as risk averse individuals. So risk averse individuals mathematically just have uh, concave preferences. On the other hand, if you were to imagine, let's say, on a similar graph, oh no, I don't want to plot this graph. Let me draw a different graph. So on a different graph, let us imagine a person who has convex preferences, convex utility curve instead of concave. So let's say utility equals to W square kind of. Now for this guy, if you were to give him a lottery between two situations, let me just roughly draw it. So suppose this is his current well W naught. Either you give him this option of W naught plus H or W naught minus H. So if he were to participate in this game, his expected utility will be here. Whereas when he was not participating, his expected utility, his certain utility was here. So obviously now expected utility is larger as compared to not participating. So such person would participate in the fee. Right? So such a person is going to participate in this game. Now, but you see, here this person has the option to pick this game. So he can pick either to be at W naught or to be at W naught plus H or W naught minus H. Sorry, this should be a minus sign here, not. So he can choose to participate in this game or not. But on the flip side, there are certain individuals who are stuck at playing this game. So suppose you are in an agricultural business and your profits depend on how much rainfall you get in a particular year. So if the rainfall is good with half probability, you get W naught plus H. But if the sorry, this should be W naught plus H, this should be W naught minus H. My bad. With half probability, you end up at W naught minus H. So here you have an individual who, without choosing, he by default is playing this game of uncertainty. All right, so he is playing this game of uncertainty by default, right? So for this guy, suppose he, when playing this game, he is at this level of expected utility. Now, instead of, so right now he's playing this game where he ends up at W naught minus H or W naught plus H with equal probability. So his expected wealth is half times W naught plus H plus half times W minus H, which is basically equal to W. So this is his expected wealth. But he's not caring about, he does not care about expected wealth. What he cares about is expected utility. His expected utility right now is this much. Now, notice that he can get the same level of expected utility if he were to get this fixed amount of income W prime. A different color. A fixed amount of income W prime. So for a W prime less than W naught, his expected utility at his certain utility at W prime or W bar is same as his expected utility from playing this game. So suppose, imagine this story that this is a farmer who is stuck with this sort of a situation where he gets W naught plus H with some amount and W naught minus H with some amount. Now a firm comes to him and says, okay, suppose there's a new factory which starts in his neighborhood. So he can leave farming. He can quit farming and he can go and work in this industry. So he will work in this industry if the industry offers him a wage greater than WR. So if the wage of the industry is here, he is happy to work for this industry as a daily wage labor. So even though his expected wealth will fall here, his expected wealth will fall by taking his job, but his utility will be larger than his expected utility from playing this game of uncertainty. Is this point clear? Everyone, is this point
Hello,
clear to
sir.
everyone? Yeah.
So I'm not getting the point W bar. मतलब W bar
You
means
see
वो
this?
खरीद ले. Yes, sir.
So
Hello.
W bar is a fixed income at which he gets the same utility as this one. So for example, let me show this example. Let me show you this example. Mm, Suppose there's this farmer who gets a wealth of 400 with probability half on a rainfall, or a wealth of 900 with a probability half on a good rainfall, right? So what is the expected utility of the farmer if his utility function is under root W? What will be the expected utility of the farmer? Rityan,
Yes, sir. So
what would be
half
the
into root 400 plus
yeah,
half into root 900.
which is
Oh, 400. Yes, sir.
25, right?
Yes, sir.
So what amount of certain income, suppose instead he got a certain fixed wage W, what amount of certain wage W can ensure that he gets this utility of 25? Wage such that utility from this W bar is equals to 25. What W bar can ensure that he gets a wage of 25? No uncertainty, a fixed wage, you get it at the end of the month, you get the same wage. So what fixed wage can ensure that gets to 25 level of utility?
So 625, 25 square.
Yeah, very good. All right. So in the initial situation, Ratyan, what was the expected utility of this guy? Sorry, expected wealth of this guy,
So half into 400 plus half into 900.
which
So
is
650.
so you see at 650 expected wealth, he was ending up at the expected utility 5. But at 625 fixed wealth, he also again ends up at the utility of 25. So that's what I mean, that you can imagine this W naught as 650 and this W bar as 625. Right. So instead of putting him in this uncertain situation where he's either rich or poor with some probability, you give him a fixed income which is lower than his expected wealth, and he'll be happy to take the job. Right.
Okay, sir,
In
got
fact,
it.
this difference between his expected wealth and the fixed amount of wealth that he gets is known as his risk premium. This is the premium he's willing to pay on his income if you can end the uncertainty in his life. All right. So suppose there is no factory which is opening up, but there's this insurance company which says that, okay, you buy our insurance, and then no matter what, we will put you on this uh, at this 625 level of income. Okay. So in that case, this is the amount of premium that is willing to pay to this particular industry in order to get out of this entire situation. The calculations are same which you just did. Okay, the calculations are going to be just the same. All right, so we find the expected utility, then we find the certain wealth at which he gets this same utility. This is known as a certainty equivalent. Okay, so this is known as the certainty equivalent. Okay, so so let me change the question. So question is, suppose he gets a wealth of 400 with probability 1 by 3 and 900 with probability 2 by 3. So find the certainty equivalent of this test. Again, utility equals to under root of n. Utility is still same, under root of n. So what is the certainty equivalent if he gets 400 with probability 1 by 3 and 900 with probability by 3? So Kritika, I am looking for an answer from you. And Vinay, you have to tell me the risk premium.
Okay.
It has to be a left. All right. So Vinay, if you can just tell us both the questions, both the answers. Expected utility will be 1 by 3 root 400 plus 2 by 3 root 900. So that is 20 by 3. Yeah, Vinay, do you have an answer for me on certainty equivalent?
So 80 square by 3.
80 square by 3 or 80 by 3 whole square? Which one is it?
Yeah, 80 by 3 whole squares.
80 by 3 whole square. Okay, let's see. So 20 by 3 plus 30 into 2 by 3, so 60 by 3. So that is 80 by 3. Yeah, so this is the expected utility. So the certainty equivalent is going to be W bar, which is expected utility square, which will be 80 by 3 whole square.
This is certainty. Risk premium is 22.22.
Okay, thanks, Kritika. So the risk premium. For the risk premium, I have to find the expected wealth first. So I know the certainty equivalent of 6400 by 9. This is the certainty equivalent. I will subtract this from 400 by 3 plus 900 into 2 by 3. So that's 1800. So this becomes 1800 plus 400. So that's 2200 by 3. So this is 2200 by 3 is nothing but 6600 by 9. So that's 200 by 9. So this is your risk premium. So simple type of questions, not very difficult questions. So this is something similar was asked in IIT Jam this year. So you can expect for on these lines, not very complicated. So this is another type of common such concave increasing function which is used in exams, utility equals to log of wealth, because log function is also concave and increasing. So this is another one which you can expect in exam. So this is an example on log of wealth. So you can try doing it on your own later on. Okay. All right, let's start with game theory. Let me start a new recording for this.